Hi everyone, this is our topic, Indoor Escape Navigation System, which aims to help people escape in a fire. And these are my team members. As we know, fire is one of the most fatal disasters. It can take place at any time and any place. This picture roughly records the fire's occurrence in last 3 days. Our members are surprised for this. We are shocked that there are so many fires occurred at every single day. Then we decided to get more information about the fire. According to internet, we got some data. As we can see, most fire deaths are the result of smoke inhalation rather than burns. Over 70% of deaths are related with smoke. People within a high office building often face challenges to get out if there is a fire. Because of the complex architecture and thick smoke, they often forget directions and become disoriented. So we conducted a survey to gather information about people's knowledge with respect to fire regulations. 64% people would leave the place when hearing a fire alarm, and the rest of people think the situation is not urgent. Therefore, they just keep doing their things. And more than 90% people would choose stairs to escape rather than lifts or window, which is good. About 66% people understand the correct fire exit route, and the rest of people take entrance route as the escape route, which is usually not the case. During this situation, we decided to develop an indoor escape navigation system to help people gain a better chance to survive in a fire. Our system is closely related with 3 parts: indoor navigation system, AR glasses, and Bluetooth. In recent years, there are 2 main methods to locate people: triangle position algorithm based on wireless network, and dead reckoning. Nowadays, people wear AR glasses on a daily basis. The AR glasses could help humans in every aspect of life. Besides, smart buildings are nothing rare. Every smoke alarm inside the building has a Bluetooth 5.0 beacon. Bluetooth 5.0 is the latest version of Bluetooth standard. It provides a new topology called Bluetooth Low Energy Mesh Networking, which supports many-to-many device communications. So these smoke alarms could connect with each other, and they are used for locating people in short range and transferring data with fire safety system.
Our system contains 3 major components: communication, computing, and presentation. The communication component supports Bluetooth 5.0 to let our system connect to the building's fire safety system and exchange data with nearby Bluetooth beacons. The computing component digitalizes the indoor maps, converts the received signal strength to relevant distance, calculate our location, and then calculate the best escape route. Once we have the best route, the presentation component will present it on the AR glasses. Based on the design, we achieved 3 major features: map acquisition, navigation, and SOS. When the user reaches the entry of a building for the first time, the entry connection Bluetooth beacon will send a request to our system. The system will then ask the user for permission to connect to the building's fire safety system. Once connected, indoor maps, including markers of emergency access, smoke detectors, and rooms with water supply, will be downloaded to our system. Whenever our system receives a fire alarm, it turns into active mode immediately. In active mode, our system conducts self-localization using nearby beacon signals and addresses. We also use the embedded inertial sensor to correct the location. then calculate and update the best escape route dynamically. If the building's fire safety system finds out a heavily smoky path that is no longer accessible, the blocked path will be broadcasted in the whole network. Our system will update the escape route to avoid this dangerous zone once it gets this information from a nearby beacon. If our system cannot find any possible escape route, our system will turn into SOS mode and calculate a nearby safety shelter for the user to go and stay. A tea room with a balcony can be a very good shelter since it has water supply and access to the outside. In the meanwhile, our system will keep broadcasting a SOS signal to inform the building's fire safety system the situation and ask for help if there's any rescue force nearby. Our system will also keep calculating for the escape route. After all, we should never lose hope. Here is a demo of a user using our system. Our user is inside the old engineering building when a fire alarm starts ringing and navigation starts working. The user followed the arrows on his glasses and successfully reached the emergency exit to the outside world.
To evaluate the performance of our system, we use the following factors as criteria. First, we use our system to calculate the routes for different maps. These maps have various structure and exist numbers. The routes calculated by our system should be the same as we calculate. For the second factor, we run our system for a long time and log all the usage information of it. The key data should not fluctuate too much, and the resource consuming should remain at a low level. We also did comparison tests to evaluate if our system have really met the requirements of our scans, and if our system can really help people in emergency. The people were divided into two groups. One used our system and one don't. They were put in 3 scenarios, and some key data were recorded for analysis. In the first scenario, the behaviors of the two groups are similar. However, in the rest 2 scenarios, the experimental group had a better performance. The people of that group can keep away from the damage of smoke or fire under the guide of our system. A phenomenon found in the comparison test is that all the testers were going to the same escape route, though there were another route with fewer people. The reason is that our system will give the best route only based on the information related to the fire condition. In the future, a solution should be given to detect the people flow and use this factor to optimize the result. The test we have done is just a start and show an initial result. More tests have to be done to evaluate our system more comprehensively.